Hello all, today in this video I am going to provide an implementation in Python for that is the intrusion detection, especially with CSV file only we are going to do. So as usual, in first of all we have to declare the library. So then our libraries which we are going to use here, since we have using CSV file, we are using numpy and also panda, so we can just run it. So it has been declared. Then the that is since we are using IoT intrusion detection, the data sets regarding it, this data set is downloaded from Kaggle. So I'm just downloading and downloaded from Kaggle, and we are just importing the data set, and we have called all the data set in this file, and we have concatenated everything in a single file. So we can just load the data set and concatenate into pd.concat. By using that, concat is used to concat that data set. So then in the third file, we are just grouping it. So next, these are the things which are given in the data set. Here we are just providing simple artificial neural network classification only. So in that we are also using a kernel initializer. So here we are just providing the definition. So this we are going to use in the later steps. Now we are just calling the training data. It's label which we are going to use in for training. Then we are going to do the model defining. As I said, we are just going to do simple artificial neural network model only. So for that I'm using the libraries like the sklearn. In that we are just calling train test split, then metrics to use the metrics variable like precision, recall, fn score, etc. Then models, layers, and also callbacks. Then we are splitting the data set into 2.5, that is test size is 0.25, that is 25% we are using testing, and the balance 75% we are using for training. So if you want some different test size, means you have just to modify in this line. Since we are here, we are using 25%. If you need some other means, you can just modify. So now the layers, you can see the layers which we have used. We have given the dimensions, and then since our layer is an binary classifier, here dense we have just used one. In binary we have only need to use only one. If it is multi-class classification means, for example, whether it is 3 means here we have to give 3. Then since it's an multi-class binary classification, we are just use the categorical cross entropy and declare the early stopping. So early stopping, what it will do is, if the since we have given 100 approaches, since it is the for some 5 to 10 approaches, here we have to give to check how many approaches. So it patience is 5, so for 5 approaches it will check what is the loss, whether it is not changing much means after that, after 5 approaches it is just normal and not changing to various extent means it will just stop, and as early stopping. So now we are training the model. Since we have given 100 approaches, this work will run for 100 approaches, and also we have given early stopping. So once we have got some no, convenient, that is no big difference for 5 approaches means, the early stopping will initialize, and just the approaches will get stopped. So you can just see for every approaches the loss is decreasing and also the accuracy is increasing. So for a better model, you may know the loss should decrease and accuracy is increased. So by that only we can just confirm that our model is good. Moreover, working with the loss and accuracy, we will just see the validation loss and validation accuracy. In some cases, we will just get a better loss and better accuracy, but not better validation loss and better validation accuracy. It is just due to this some issues like overstopping, overfitting, underfitting, and all. So here in the ninth portion itself, it has stopped since it has getting some regular. You can see for 5 approaches the loss. Here we have just checked loss. You can also give accuracy to check. In the early stopping, here we have given the loss variables. Here you can see if you want to check some accuracy, validation accuracy also, you can just change it as validation accuracy. So this is the code for this. So then we are going to plot the validation loss and the validation accuracy graph. So here since it's given as accuracy, but in this code it is given as ACC. We have to just change this. So after we can run, now we have also got the validation accuracy graph. You can note that the loss is decreasing and the validation accuracy is increasing. Just for a better system, it should look like that only. So now we are just testing this model. Now you can see the accuracy is 88. So this is a simple ANN model for working with CSV file. You can just use this. And in the next video, we can see some other Python or MATLAB related task. Thank you.